Welcome students to the YouTube channel, that is Real Edutainment. Today we are going to discuss the numericals of chapter number 2, that is motion in one dimensional. That is, in last session we have started or we have completed first exercise numericals, and in this session we are going to take second exercise numericals. So let us start. Second exercise numericals is basically with respect to graphical representation of your motion. So all the numericals in the second exercise are based on graphical representations. So let us see one by one all the numericals and let us try to analyze and solve these things. Okay. So here is your first question from exercise 2B of class 9th ICSE textbook. Okay. So here the question goes like this. Figure 2.37a shows the displacement time graph for the motion of a body. Use it to calculate the velocity of a body at t is equal to 1 second, 2 second, 3 second. Then draw the velocity time graph for it in figure B. Okay. So by this question we have understood that in figure A the data has been given, that is displacement with respect to time graph has been shown here, and we need to draw velocity with respect to time ka graph. Okay. So let us try to analyze once more the same question, that is figure 2.37 shows the displacement time graph. This is displacement time graph for the motion of a body. Use it to calculate the velocity of a body at t is equals to 1 second. We need to calculate at t is equal to 1 second. What is the velocity? T is equals to 2 seconds and t is equals to 3 seconds. So for these time slots, we need to calculate the velocity and then draw the velocity time graph. Okay. So very simple. What is the velocity formula? Formula for velocity we all know, that is displacement upon time. Okay. So this is the basic formula for velocity, that is displacement upon time. Now there are three conditions mentioned over here, that taking t is equals to 1 second, 2 second and 3 seconds. So suppose if we take t is equals to 1 second. Okay. So from the graph we can see at 1 second what is the displacement? It's in meter, that is 2 meters, it is covering 2 meters. So what will be the velocity? For 1 second the displacement is 2 meter. So what is the velocity? Velocity is 2 meter per second. Very good. Then what about t is equals to 2 seconds? For t is equals to 2 seconds, the formula will be displacement upon time. So for 2 seconds, what is the displacement? It's 4 meter. It's showing 4 meter. Again 2 ones are, 2 twos are. The velocity is 2 meter per second. Right? And the last one is t is equals to 3 seconds. If we take 3 is equals to 3 seconds, then what will be the velocity? In the same manner, displacement upon time. Time is 3 seconds. So from the graph, for 3 seconds, the displacement is 6 meters. 6 meters. So 3 ones are, 3 twos are. Again, we are getting 2 meter per second. See, for time slot, t is equal to 1 second, the velocity is 2 meter per second. For t is equal to 2 seconds, the velocity is 2 meter per second. And again for t is equal to 3 seconds, the velocity is 3 meter per second. That means for each instant of time, we are getting same velocity. Okay, that means velocity is constant. And then they are asking us to draw the velocity time graph. So for 1 second, for 2 second and 3 second, what is the velocity? It is constant. That is 2 meter per second. 2 meter per second. So how we can draw? We can draw like this. It's 2 meter per second. It's a constant value. It's a constant value. Right? Here is the graph. for 1 second, 2 second and 3 second. And if we go for 4 also, then also it is coming 8 displacement. So that is 4 by 8 is again 2. Then it will goes like this, constant term, right? The graph for velocity with respect to time is a constant graph. That means velocity is not at all changing, right? Getting these things. So from the first question, we came to know the velocity ka formula, that is displacement upon time, and they have asked us to calculate the velocity for t is equal to 1 second, 2 second, 3 second, and hence draw the graph. So for t is equal to 1 second, we have got 2 meter per second velocity. T is equal to 2 seconds, we have got 2 meter per second velocity, and for t is equal to 3 seconds, we are getting the same value as 2 meter per second. So the graph would be constant for velocity versus time ka graph. Okay, getting everyone? Okay, chalo, let's get to second question. Question number 2. Okay, very interesting. Following table gives the displacement of a car at different instants of time. This is the table showing different instant of time with respect to displacement. Different instant of time with respect to displacement. Okay, so the question goes like this: draw the displacement time sketch and find the average velocity of a car. So it is the question of vice versa. Here the table is shown and we need to draw the displacement time graph. Okay, chalo, let us try to analyze. So let us take, suppose we are taking on x-axis, let us take time period which is in seconds, okay, and on y-axis let us take displacement. Okay, on x-axis time and on y-axis displacement. Now, for times, instances are given like 0, 1, 2, 3, 4. So we will take the same probability like 0, 1, 2, 3, 4. Okay, and what will be the displacement? The displacement slots have been given like 0 meter, 5 meter, 10 meter, 15 meter, 20 meter. So we need to first select the scale. So for that purpose, take the same range only because it's a standard value: 5, 10, 15, and this one is 20 in meters. Okay. For 0 seconds, the displacement is 0 meter. For 1 second, the displacement is 5 meter. For 1 second, the displacement is 5 meter. For 2 seconds, the displacement is 10 meter. For 2 seconds, the displacement is again 10 meter. For 3 seconds, the displacement is 15 meter. For 4 seconds, the displacement is 20, right? And if you draw a straight line, it will go like this. Okay, so this is the graph they have asked us to draw. So we have initiated to draw this graph like this. Okay, so this is the it is increasing linearly with respect to time. The displacement is increasing linearly with respect to time. That means from this graph we can say the velocity is constant. Okay, and find the average velocity, and they are asking us to find the average velocity. Okay, they are asking us to find average velocity. So average velocity is total distance upon total time. Average velocity is total displacement upon total time. So what is total displacement? It is 20 meters. 20 meters. And what is the total time? It's 4 seconds. So what is 20 upon 4? 20 upon 4, 4 ones are 4, 5. So average velocity is 5 meter per second. Average velocity is 5 meter per second. Hence, we have completed this first question from question number 2, A section. Now, let's come back to B section. What will be the displacement of a car at 2.5 second and 4.5 second? What will be the displacement of a car at 2.5 second and 4.5 second? What will be the displacement of a car at 2.5 second and 4.5 second? For this, we can go by my method, like for 2 seconds, it is completing 10 meter. For 2 seconds, it's completing 10 meter. Then for 2.5 seconds, how much distance it will complete? So let us suppose x distance. Okay. Now, how to calculate? By using these two equations, just cross multiply the things, right? That is x into 2 is equals to 10 into 2.5. So what is the value of x? X is equal to 10 into 2.5 upon 2. 2 ones are 2 5s are, right? And 5 into 2.5 we are getting, therefore x is equals to 5 5s are 25 and 5 2s are 10, that is 12.5 meter, right? For 2.5 seconds we are getting 12.5 meter. This is what we are getting. Now try the second sum now. For second question, that is 4.5 seconds, how much more the distance will travel for 4.5 seconds? Suppose, how to compare? Let's compare with 4 only. For 4 seconds, it is traveling 20 meter. For 4 seconds, it is traveling 20 meter. Then for 4.5 seconds, how much it will travel? Let us assume this is y. And just cross multiply these two equations, you will get 4y is equals to 20 into 4.5, right? Then what is the value of y? 20 into 4.5 upon 4. 4 ones are 4 5s are. Then what is the value of y? 5 5s are 25, 5 4s are 20, 20 plus 2, 22.5 meter. 22.5 meter. 22.5 meter. 22.5 meter. 22.5 meter. This is what the answer to be achievable, right? So by this you can attempt the n number of questions on this same kind of numericals, right? Now, getting everyone? चलो, next question पे जाते हैं अभी. The next question goes like this. A body is moving in a straight line and its displacement at various instants of time is given in the following table. This table represents the time and displacement. For 0 seconds, the displacement is 2 meter, for 1 second 6, and so on. Plot the time displacement time graph and calculate. So first of all, let's plot the displacement time graph. So to plot the displacement versus time graph, scale is very important. So how to take a scale? Just take the scales of time instance as it is only. There is 0 second, 1 second, 2 second, 3, 4, 5, 6 and up to 7. What about this? Now, here how you can manage to take the scale? So start from 4, 8, 4, 8, 12, 16, 20 and then 24. Okay, so we'll start from 4 and then 8, then 12, then 16, then 20 and then 24. Okay, yes, yeah, this will do. Now we need to draw the graph, plot displacement time graph and calculate. First we need to plot the graph. For 0 second the displacement is 2 meter. For 0 seconds the displacement is 2 meter. It is somewhat coming here. Okay, first plot. Second, for 1 second the displacement is 6 meter. For 1 second the displacement is 6 meter. Okay, next, for 2 seconds the displacement is 12 meter. For 1 second it was 6 meter, and now for 2 seconds it is coming like this. Okay, now next, for 3 seconds the displacement is 12. For 3 seconds the displacement is 12. Okay, for 4 seconds the displacement is again 12. For 5 seconds the displacement is 22. Okay, and for 6 seconds, oh, for 5 seconds it is 18. Sorry guys, for 5 seconds the displacement is 18. For 5 seconds the displacement is 18. And for 6 seconds the displacement is 22. And for 7 seconds the displacement is 24, right? So here we got all the numeric like this, 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 this and this. Okay, so in that way you will have the graph with respect to the following data information given on the table. Now what they are asking us, total distance traveled in 1 second to 5 second. From 1 second to 5 second, from 1 second it is 6 meter, and to 5 seconds it is 18 meter. To total distance, so first question, total distance from 1 second to 5 second is 18. For 5 seconds it has traveled 18 meter, minus for 1 second it is traveling, it is traveled 6 meters. So 18 minus 6 is 12 meter. Okay, and for second question, average velocity in time interval 1 second to average velocity in time interval 1 second to 5 second. Same, 1 second to 5 second. Average velocity is total displacement upon total time. So for 1 second to 5 seconds, what is the total displacement? Total displacement is 12 meter, what we have seen in above. Okay, 12 meter. upon total time from 1 second to 5 seconds is 4 seconds, right? So 4 ones are 4 threes are, we are getting answer 3 meter per second, the required answer. Getting everyone? Understood? Okay. Chal. Next sawal. Figure 2.38 shows the displacement of a body at different times, right? This is the question. We have got one graph over here, that is displacement with respect to time. So in that first question, they are asking as calculate the velocity of a body as it moves from time interval 0 to 5 seconds. 0 to 5 seconds is a displacement versus time. Okay, graph. So what is velocity? Displacement upon time, right? So they are asking from 0 to 5 seconds. What is the displacement? From 0 to 5 seconds, the displacement is 3 meters. So 3 meter upon time is 5 seconds. So 3 meter upon 5 seconds, that is 5 ones are 5 zeros are, carry 3, decimal 3 and 5 6 are 30. So 0.6 meter per second. So this is the first question which they are asking us. And what about velocity for 5 to 7 seconds? For 5 to 7 seconds, the displacement is 0. Then the velocity for 5 to 7 seconds, the velocity will also be equal to 0 because it is given here, the formula is given here, displacement upon time. The formula given here is displacement upon time. So displacement, there is no displacement, it's a constant value of 3 meter. So no displacement means the velocity will also be 0. Velocity will also be the 0, that is 0 meter per second. That is 0 meter per second. Okay. Now the third one, 9 seconds to 7 seconds to 9 seconds. 7 seconds to 9 seconds is 2 seconds. So velocity for 7 seconds to 9 seconds is distance travel for 7 seconds to 9 seconds is 3 to 7. That means 7 minus 3 meter upon total time 9 minus 7 seconds. That is 4 meter upon 2, which is nothing but 2 meter per second. The required answer 2 meter per second. Now B part. B part, it is saying like this, calculate the average velocity during the time interval 5 to 9. B part, it is saying that calculate average velocity during the time interval 5 seconds to 9 seconds. Average velocity during the time interval 5 seconds to 9 seconds. Average velocity, total displacement upon total time. For 5 to 9 seconds, what is the total displacement? For 5 to 9 seconds, what is the total displacement? Obviously 7 meter minus 3 meter. And what about total time from 5 to 9? That is 9 second minus 5 second. What is, how much is this? 7 minus 3 is 4 and 9 minus 5 is 4. 4 meter per second. That is 4 and 4 will get cancelled. You will get the answer as 1 meter per second. Understood? So बहुत छोटे छोटे and simple questions आपके सामने यहाँ पर है. Just you need to get through the formula and do some small calculations. Okay? Sure. Done with this question? Yes. B part from 9. Okay. Will do. So all the answers have been completed from this question. Chalo, next question. Question number 5. From the displacement time graph of a cyclist given, the average velocity in first 4 seconds. Average velocity in first 4 seconds. 1, 2, 3, 4. So average velocity का formula हमको पता है क्या है? Total displacement upon total time. First 4 seconds के लिए total displacement कितना है? 10 meter. From the graph it is clearly seen for first 4 seconds the displacement is 10 meter and total time is 4 seconds. Right? Total time is 4 seconds. So 4 ones are, 4 twos are, 8 carry 2 decimal point 0 and 4 5s are. That is 2.5 meter per second. This is my required first answer. 2.5 meter per second. Second question. The displacement from the initial position at the end of 10 seconds. Displacement from the initial position at the end of 10 seconds. From the graph it is clearly understood the displacement is going upward, then constant, then coming downward and then going for negative slope, then getting minus 10. So they are asking the displacement from the initial position to the end of 10 seconds. 10 सेकेंड तक डिस्प्लेसमेंट 0 से कहां तक आया? 0 से -10 तक आया. So displacement is -10 meter. Getting everyone? Chalo, next question is the required answer. Next question. Third question. The time after which he reaches starting point. The time after which he reaches starting point. पहले यहां गया, फिर constant displacement था, कुछ displacement ही नहीं था, फिर रिटर्न आया starting point. So this is the starting point. फिर पीछे गया, फिर कुछ देर चलाया नहीं साइकिल, फिर starting point पे आ गया. So from the time after which he reaches the starting point. Starting point का time कहाँ पे? That is 7 seconds. The third answer is for 7 seconds and for 7 seconds and for 13 seconds. ठीक है? For 7 seconds and for 13 seconds. Clear? Okay. The required answer. Next. Figure 2.40 ahead represents the displacement time sketch of a motion of two cars A and B. This is car A and this is car B. Okay. And they are asking the following things. First question. The distance by which car B was initially ahead of car A. The car B was initially ahead of car A. The car B means this red line and the car A means this red line. Okay. So initially car A पीछे था और car B आगे था. So they are asking by what distance the car B was ahead of A. So by what distance? From the graph it is clearly, it can be seen that is 40 kilometer. So first answer is 40 kilometer. Okay. Next question. The velocity of car A and B. The velocity of car A and B. Velocity of car A and B. So second. Velocity of car A. What is velocity of car A? Let us take average velocity total. Displacement upon total time. What is total displacement of A? A means this one. Suppose let us consider it is going till 4 hours. 4 hours, how many kilometer it has crossed? 160. So 160 by 4, that is 4 ones are, 4 fours are, this 0 upper, that is 40 kilometer per hour. This is VA. What about VB? VB. Let us take 4 hours only, and in 4 hours it is completing 120 kilometers. So VB is same formula, total displacement upon total time. Total displacement, let us consider 120 kilometer upon in 120 kilometer, how much time it will take? 4 hours. So 4 ones are 4 threes are, that is yes, exactly. Actually here for VB, see guys, don't do this kind of mistake. For VB, the initial position is already at 40 kilometer, right? So for taking 4 hours, you need to consider from total displacement is 120 minus 40 upon 4 hours, right? So 120 minus 40 is 80 upon 4. 4 ones are 4 twos are, that is VB is 20 kilometer per hour. VB is 20 kilometer per hour. VA is 40 kilometer per hour. VB is 20 kilometer per hour. Okay. Now the third question. The time in which car A catches the car B. The time in which initially car A was behind, lagging, and car A was ahead, 40 meters ahead. So by which time they both meeting together? From the graph it is clearly seen at 2 hours. At 2 hours, right? Third one. The time in which the car A catches car B is 2 hours. Okay. Next question. Last question. Fourth, the distance from start when the car A will catch the car B. The distance from start when car A will catch B. The distance from start when car A, this is car A ka graph, will catch B. So this is, as by graph it is clearly showing, that is 80 kilometer, right? The required answer 80 kilometer. Understood? Okay, chalo. Let's go to next question, that is question number 7. Okay. So question number 7, a body at rest is made to fall from top of a tower. A displacement at different instants is given below. Draw a displacement time graph and state whether the motion is uniform or non-uniform. So let us draw the graph. Let us try to draw the graph. Time in seconds. So first we will take 0.1 second, second we will take 0.2 second, 0.3, 0.4, 0.5 and 0.6. Okay. So this is the time versus displacement. Now for displacement, we need to achieve certain values, certain constant values, so that our scale is fitted in this graph. Okay. So the values are here mentioned over here, like 0.05, 0.2, 0.45, 0.80, 1.25 and 1.8. So how to take? So let us take small units of 0.10, right? 0.10, like this is 0.10, this one is 0.20, this one is 0.30, this one is 0.40, this one is 0.50, this one is 0.6, next 0.70, 0.80, 0.90 and 1.0. और कितने करने हैं? 1.10, 1.20, 1.3, 4, 5 and so on up to 1.80. Okay. Then they have asked us to draw the graph of time, displacement and time graph. So how to draw? For 0.1, for 0.1 time the displacement is 0.05. 0.1 the displacement is 0.05. For 2 seconds the displacement is 20. For 2 seconds the displacement is 20. For 3 seconds the displacement is 45. For 3 seconds the displacement is 45. For 4 seconds, 0.4 seconds, the displacement is 80. For 0.5 seconds, the displacement is 1.25. And for 0.6 seconds, the displacement is 1.8. Okay. And if we join all this, okay, so in this way we achieved the graph of displacement versus time. And now they have asked one more thing and state whether the motion is uniform or not. By this graph, can we say the motion is uniform with respect to time? No. For the motion to be uniform, the displacement time graph should be linear. But is it linear? It should be like this, right? But is it like this? No. Okay, so therefore the given graph or the given motion is non-uniform. The motion is non-uniform. The motion is non-uniform. Okay, sure. Next question. Question number 7. Yes. Figure 2.41 shows the velocity time graph for the motion of a body. Use it to find displacement of the body at t is equals to 1 second, 2 second, 3 second and 4 second, and draw the displacement time graph. Okay, they have given the graph of velocity with respect to time. They are asking us to draw displacement versus time ka graph. But before that, they are asking us to find displacement of a body at t is equals to 1 second, 2 second, 3 second and 4 second. So displacement. So what's the formula for velocity? Velocity is displacement upon time. Then what is displacement? Displacement at 1 second will be is equals to velocity at 1 second and time, that is 1 second. So what is the answer? Velocity at 1 second is 1 meter per second. 1 into 1, that is d1 is 1 meter. What about d2? d2 for d2, v2 into t2. What is v2 for t2? For 2 seconds velocity is 2, that is 4 meter. Similarly for d3, v3 into t3 is 3 seconds. The velocity for 3 seconds is 3 meter, that is 9 meter. And what about d4 v4 into t4, right? So velocity, it is 4 seconds into 4 meter, that is 16 meter. Okay. So here you can see the displacement is also increasing with respect to velocity. If we are continuously increasing the velocity, acceleration would be constant, but the displacement is also varying. So how it will vary? Chalo, let us plot the graph. Let us plot the graph, time versus displacement graph. So for 0 seconds, it will be 0 only. Okay, for 1 second, the displacement is 1 meter. For 2 seconds, the displacement will be 4 meter. For 3 seconds, the displacement will be goes over here up to 9, and for 4 it will go up to like here, somewhat like 16. If you will draw the graph, it is coming like this. Okay, because it is somewhat smaller than the required data, so ultimately you will get the graph like this of displacement versus time. Okay, fine. Chalo, next question. Okay, that is question number 9. Figure 2.42 given below shows a velocity time graph for a car starting from rest. The graph has 3 parts: AB, BC and CD. The question is, state how is the distance travelled in any part determined from this graph. How the distance travelled in any part determined from this graph. See, here velocity is constant, here velocity is accelerating, and here velocity is retarding. Okay, first question, state how is the distance travelled in any part determined from this graph. So from this graph, the graph shows velocity versus time. So how to determine distance? Distance can be determined, distance can be determined by area enclosed by that part or region. Okay, distance can be determined by area enclosed by that part or region, right? For example, if I want to determine this AB part, how much distance it has been travelled. So we need to find the area enclosed by this region, okay, or by this part. Okay, if I want to determine the part BC, for BC how much distance it has travelled, so I need to find this area enclosed by that BC. And if I wanted to find CD, for CD I need to determine this region ka area. Okay, so by determining the area enclosed by that part, we can definitely determine the distance. Okay, next question, compare the distance travelled in BC with the distance travelled in AB. So let us first find out the distance travelled by BC. Distance BC. Okay, so as I have said, to find the distance travelled in this region, I need to find this area enclosed by BC. So enclosed by BC is area. Area enclosed by this region is length into breadth. By this region is length into breadth. By this region is area of rectangle is length into breadth. Area of rectangle is length. What is length? 2t minus t. What is breadth? V naught. So 2t minus t is t and to V naught, that is we get V naught into t. This is the distance traveled in the part BC. Now they have asked us BC and the distance traveled in AB. Okay, let us try to analyze this as well. Distance traveled in AB. This is in the form of triangle. So distance AB is equals to half into base into height. So what is half into base? What is base? Base is 0 to t. And what is height? What is height? Height is V naught. So this is V naught t by 2. Okay. So this one is first question and this one is second question. Now what about third one? Which part of the graph shows motion with uniform velocity, acceleration and retardation? Uniform velocity means constant velocity they are asking. Constant velocity, which part we can see the constant velocity is BC, the part BC. So we can write uniform velocity for uniform velocity the region is BC. For uniform acceleration we can see the region is OA, and for uniform retardation the region is CD, right? Because the velocity is decreasing over here, so that's why it is known as retardation. Okay, and the last question, is the magnitude of acceleration higher or lower than that of retardation? Give reason, compare the magnitude of acceleration and retardation. Just take down these notes, we will go for the last one. Okay. Okay, sure. We will do here. Okay, is the magnitude of acceleration higher or lower than that of retardation? First of all, let us try to find what is acceleration. How much is the acceleration here? So acceleration part, which part is showing acceleration? That is OB. Acceleration OB. What is the formula for acceleration? Velocity upon time. What's the velocity over here? Velocity is V naught and upon time is t. Okay. And what is the retardation? Second, retardation. Retardation is velocity is decreasing, that is CD. Then what's how much is the velocity over here? It is retarding V naught to 0, that is minus V naught upon, or it is retarding, so we don't need to write minus sign over here, just we will take the magnitude only. Okay, so this is V naught upon time. It is 2 to 2.5. Can I say it's 0.5 t? 0.5 t is nothing but V naught by half t. Half t is 2 V naught by t. Okay, 2 V naught by t. 2 V naught by t. 2 V naught by t. So, and if I wanted to compare the magnitude of acceleration and retardation, take the, this is AB, take the ratio of acceleration to retardation. If I'll take the ratio of acceleration to retardation, then I'll get the value as V naught t will get cancelled, 1:2. Right? So 1:2 means retardation is twice of acceleration. Okay, retardation is twice of acceleration, right? Okay. Done with all the questions? Okay. Chalo. Next question. Okay, the velocity time graph of a moving body is given below in figure 2.43. Find the acceleration in part AB, BC and CD. So For part AB, we can see it is uniform acceleration, and for part BC, the acceleration is 0 because velocity is constant, and for part CD, the acceleration is velocity is decreasing, that means it is in retardation. Okay, the acceleration in part. Chalo, let us try to analyze acceleration. We all know acceleration ka formula, final velocity minus initial velocity upon time. What is final velocity? Acceleration final velocity is 30. है ना? Final velocity is 30 from this graph. For OA, OAB, final velocity is 30 minus initial velocity is 0 upon total time is 4. So 30 upon 4. What is 30 upon 4? 4 ones are 4 sevens are 28, carry 2.5, 4 fives are, that is 7.5 meter per second square. Clear? 7.5 meter per second square. For BC, the acceleration will be 0 because initial and final, the time we can take in, but initial and final point will be same. So the acceleration will be 0 over here, right? And what about third one, CD? For CD, the acceleration is initial, final minus initial, that is 0, final is 0, initial is C, that is 30, 0 minus 30 upon how much time it is taking? It is taking 2 hours. So that is 30 minus 30 upon 2, which is nothing but minus 15 meter per second square. Minus 15 meter per second square. These are the required answers. Okay. Now, second one. Displacement in each part. See, whenever the velocity versus time graph is given, how to determine the displacement or how to determine the displacement? It is simple. Just take the area enclosed by that part will give you the displacement. So for AB, we need to take this area enclosed by it. So displacement AB, area enclosed by it. What is area enclosed by it? Area enclosed by it is half. It is in the form of triangle, that is half into base into height. So half into base. What is the base? That is 0 to 4. 4 into height. What is the height? 30. 30. 4 into 30. 1s are 2s are. So answer is 60 meter. Answer is for AB 60 meters. Likewise for BC, displacement for BC, we need to take this region. It is in the form of rectangle. So length into breadth. What is the value of length? Length is 4 to 8, that is 4 meters. And what is breadth? Breadth is 30. 4 into 30 is 120 meter. Okay. So this is 4 meter. It's 4 hours. Sorry. It's 4 hours. So the total value will be 120 meters. Right. So BC. What about the last one, that is CD? So we need to take this triangle, this small triangle. For CD, the equation is half into base into height. Half into base. Base is 8 to 10. 8 to 10 means 2 hours. And height is 30. So 2 will get cancelled. That is 30 meters. Okay. So the displacement is 30 meters for CD. And the last question is total displacement. Total displacement means this region displacement, this region displacement, and this region displacement. So add all those displacement, that is 60, 120 and 30. So the third point is total displacement. So what is total displacement over here? For first part, the answer is 60 meter. For second part, the answer is 120 meter. And for the last part, it is 30 meter. Right? So 120, 60, 180, 180, 30 is 210 meter is the final answer. Okay? Getting? Very easy question. Chalo, next question. A ball moves on a smooth floor in a straight line with uniform velocity 10 meter per second for 6 seconds. Uniform velocity 10 meter per second and the time they have mentioned as 6 seconds. At 6 seconds, the ball hits the ball and comes back along the same line to the starting point with the same speed. Draw the velocity time graph. Very easy. Let us take time over here and on y-axis velocity. So for 10 meter per second for 6 seconds, it is a uniform velocity. That means for 10 meter per second, for 10 meter per second, for 6 seconds, 0, 1, 2, 3, 4, 5, 6. So for 6 seconds, the velocity is constant and it is striking a ball. Suppose this is my ball, okay, and comes back. That means it is going and coming back. Comes back with same speed. Same speed means almost 10 meter per second. Okay. Draw the velocity time graph. We have drawn it. And use it to find total distance traveled by the ball and its displacement. Okay. First of all, let us find distance. So distance, total distance. Total distance is, what is the formula for speed? Speed is distance upon time. Then what is distance? Speed into time. So what is the speed over here? 10 meter per second. 10 meter per second into time. Time, the speed is constant. So time will be 6 seconds. And then for coming back, it is 6 seconds. 6 plus 6, 12 seconds. 12 seconds. That means 12 into 10 is 120 meter. The answer, the distance is 120 meter. What about displacement? Displacement is 0 because it is coming back to its original, because it is coming back to the starting point. That means initial point and final point. Final point is same, then the displacement traveled is 0 meter per second. So the displacement is 0 meter per second. Okay. Next. Now, figure 2.44 shows the velocity time graph of a particle moving in a straight line. State the nature of motion of particle. State the nature. First question. State the nature of motion of particle. So, what is the nature? Velocity versus time. First of all, it is increasing. It is increasing linearly and then it is retarding linearly. Velocity is increasing linearly and decreasing linearly. That means, can I say here I can say mention it is acceleration and here I can mention it is retardation. So it is uniformly accelerating from 0 to 4 seconds and it is then uniformly retarding from 4 to 6 seconds. Getting? Second question. Find the displacement of a particle at t is equal to 6 seconds. At t is equals to 6 seconds, the displacement will be, for t is equal to 6 seconds, the displacement will be, I have told you, for velocity versus time graph, if we need to calculate displacement, then just find the area enclosed by that graph or by that region. So displacement is area under curve. Area under the curve or under the region. What is the area under it? It is in the form of triangle. So what's the formula for triangle? To find the area, half into base into height. Half into base. What is the base? 0 to 6. That is 6. And height. What is the height? 2. 2 and 2 will get cancelled. Displacement is 6 meters. The mentioned answer. Okay. Displacement is 6 meters. Okay. Displacement is 6 meter. Okay. Third question. Does the particle change its direction? From the given graph, can we say the particle is changing its direction? No. The velocity is still positive only. Throughout the entire graph, the velocity is positive. Throughout the entire graph, the velocity is positive. So, the direction is not changing. So, the answer is no. Right? Third one, compare the distance traveled by 0 to 4 seconds and 4 to 6 seconds. That means we need to take first this triangle 0 to 4 seconds and 4 to 6 seconds. So, distance traveled by fourth one. Distance traveled in 0 to 4 seconds and distance traveled in 4 to 6 seconds. So for half into base, what is base? 4, and what is height? It's 2. And what about distance traveled in 4 seconds? It's half into base into height. That is half into what is base? 2. And what is height? Again 2. 2 and 2 will get cancelled. 2 and 2 will get cancelled. 2 ones are 2 twos are. So the answer is 2:1. Okay. So we have compared the things. So the answer is 2:1. The last one. Find the acceleration from 0 to 4 seconds and retardation from 4 to 6 seconds. So the last question they mentioned here is they are asking us to find 0 to 4 seconds, what will be the acceleration? So what is the formula for acceleration? Acceleration is velocity upon time. So for 0 to 4 seconds, the velocity is 2 meter per second. The velocity is 2 meter per second and the time is 4, that is 1s are 2s are, that is 0.5 meter per second square. The answer is 0.5 meter per second square. And what is the retardation for 4 to 6 seconds? Retardation for 4 to 6 seconds, again velocity upon time. What is the velocity? It's again 2, and for time it's again 2, and 2 and 2 will get cancelled. It's 1 meter per second square. It's showing 1 meter per second square. Clear? Hope you have got all the questions and all the numericals solved over here. Just practice it again and again so that you could be master in these concepts. Okay? Thank you.